Good afternoon, Alvin ISD geometry students. Today we're going to be looking at Chapter 12, Section 4, finding the volume of prisms and cylinders. So up at the top we have our key concept. So we know from starting in 6th grade that the volume of a prism is the area of the base multiplied by the height of the entire prism. And it's important to remember that height is the distance, and it has to be a perpendicular distance, between the two bases. So we come down to example 1, and we have a pentagonal prism. So our formula for volume is area of the base multiplied by height of the prism. And to find the area of this pentagonal prism, I can use my apothem formula, which is 1/2 of the apothem multiplied by the perimeter of the base. Well, I see that they gave me the distance of my apothem, so I can substitute 3.4 in. And because it's a pentagon and I know that they're all congruent, so this is a regular pentagonal prism, my perimeter will be 25. So now I'll go to my calculator. I have 1/2 of 3.4 multiplied by 25, which gives me an area of the base of 42.5, so I can plug that in. And the height of my entire pentagonal prism is 8 millimeters. So when I multiply 42.5 times 8, I get 340 millimeters cubed. So now I can come over to example 1b, and I see this is a triangular prism, so my base is this triangle. I do not have the height of the triangle, but since I have the slant distance, I can use Pythagorean theorem. So 15 squared minus 9 squared should give me that missing side length squared. So that's 225 minus 81, which gives me a value of 144, which I can take the square root of to get my missing side length of 12. So to find the area of the base, 1/2 of base times height. So 1/2 of 9 multiplied by the height of 12. I can take 1/2 of 12 to give me 6, and 6 times 9 gives me that area of the base of 54. So I can come and plug that into my volume formula. Area of the base is 54, and then again, height is the distance between bases. So it's not 12, it's actually going to be this 10, because that's how far our bases are apart. So my volume would be 540 feet cubed. Right, so now we're going to move on to the second 3D solid, which is our cylinder. So again, our volume formula right here is area of the base multiplied by the height of the cylinder. And in this case, they've already substituted in pi r squared to help us find the area of that circle. So let's look at our first example. We want to find the volume of a cylinder with a radius of 3 centimeters and a height of 8. So I'm going to draw a cylinder for us. My radius was 3 and my height was 8. So now I can plug this into my formula, which is volume is equal to pi radius squared times height. I'm going to use 3.14 for pi. If you use the pi button, you'll get a more accurate answer. So if ours look a little different, that's okay. Radius squared and then multiplied by the height of 8. So I'm going to come to the calculator. We have 3.14 times 3 squared, which is 9, multiplied by 8, which gives me a volume of 226.1 centimeters cubed. So now we're going to move on to our next examples. And if you look here, notice now we have some slanted solids. But if two solids have the same height, so the same height, and the same cross-sectional area, which means if I sliced each of these rectangular prisms, they would have the same rectangle cross-section all the way up, which would have the same area. That means that they're going to have the same volume. So when we come down here, we have this volume of an oblique solid. So I'll have a cylinder that's kind of slanted a little bit. They gave me the radius was 5, and that the height was 3. So again, I can substitute this into my formula, which is pi times radius squared times height. 3.14 times my radius squared times the height of 3. So we'll have, let's get the calculator, 3.14 multiplied by 25, and then multiplied by 3, which gives me my volume of 235.5, and that is feet cubed. Okay. So now we're going to look at comparing volumes. So we have two cylinders. So we have the containers at the right, and they're filled with popcorn. We want to know about how many times as much the larger container holds than the smaller container. So we'll need to find the volume of each of them and then compare them using a ratio. So for the first cylinder, I see they gave me the diameter, so I'll just take half of that to find the radius. So if my diameter was 14.5, my radius would be 7.25, and the height of that prism was 18. And for the second cylinder, again, they did give me that diameter, so I'll take half of it. So I have pi, or 3.14, multiplied by the radius, in this case, which is 11.4, squared, multiplied by the height of 18. So then we'll come to our calculator. So for our first cylinder, we have 3.14 multiplied by 7.25 and 7.25, the height of 18. So we get 2,970.8 approximately. Right, and for the second one, we'll have 3.14 multiplied by 11.4, 11.4, and then the height of 18. So we get approximately 7,345.3. And we actually want to compare the volumes. So I will take this current volume and divide it by the smaller volume. And I get approximately 2.5 times larger. So then our answer choice is going to be over here, and it's answer choice G. Thank you, boys and girls.